Welcome to EDU World Space.
Okay, problem 84. We're told that we have a thin meniscus lens, a converging lens, and the radius of curvature, or radii of curvature, since we have two, are 12 centimeters and 28 centimeters, and the index of refraction of the lens is 1.6. In part A, we're told that an object is placed to the left of the lens 40 centimeters away, and it has a height of 5 millimeters, and we are asked to determine the position and size of the image. And then in part B, a second converging lens with the same focal length as the first lens is placed at a distance, which I call D, of 3.15 meters or 315 centimeters to the right of the first lens. Again, we're asked to determine the position and size of, in this case, the final image, and whether or not, and to determine the orientation of the final image. In part C, we are to repeat what was done in part B, except now that the distance between the lenses is 45 centimeters instead of 315 centimeters. So let's go ahead and do part A. So the goal in part A is to find S and to find y primed. So let's first find S using equation 34.18. So we have 1 over S plus 1 over S prime is equal to n minus 1, 1 over R1 minus 1 over R2. And meniscus lens kind of looks like that. So this can be R1 and it can be R2. So we know N, we know S, we know R1, we know R2. So all that's left to do is find S prime. So this is actually 1 over F, this whole thing. So why don't we just work out this left-hand side first so we can put it in a more familiar form, right? Then we can write 1 over S plus 1 over S prime is equal to 1 over F. And from here we can easily work out that S prime is SF over S minus F. So let's go ahead and do 1 over F is N minus 1 times 1 over R1 minus 1 over R2. And that's 1.6 minus 1 over 12 centimeters minus 1 over 28 centimeters. And that should give me 35 centimeters. So that gives me that F is 35 centimeters. You'd have to, because you'll get 1 over F is equal to here 0.0286 centimeters, inverse centimeters, and then you invert this thing here. You take this. Let's do 1 over F is equal to 0.0286. So then F is 1 over 0.0286 with centimeters on top, and that's the 35 centimeters, like so. And now that we have F, we can use this equation, and then we can write S prime. So S was 45 centimeters. F is 35 centimeters. We just found that. And then we have 45 centimeters minus 35 centimeters. And that gives us 157.5 centimeters. Okay, so now we have the position of the image that's formed by that lens. And now we can find, so now we need to determine y prime. So remember, we found s prime is 157.5 centimeters. So we can use m is equal to minus s prime over s in this case. And that's minus 157.5 centimeters divided by 45 centimeters. And that gives us minus 3.5. So m is less than 0. The image is inverted. And now we could use m is also equal to y prime over y, which tells us that y prime is m times y. So we have 3.5 times the height of the object, which is 5 millimeters. And that gives me 17.5 millimeters. So that now is the height of the object. And now we can move on to whatever we're asked to do in part B. Okay, so now in part B, we have another lens, another converging lens that's placed 315 centimeters away from the first. So we have like a picture. Let's draw a picture. You have your object over here, and then there's your first lens, and then there is your second lens. So this thing was 45 centimeters. So that's our distance S1. And it had an image, I don't know, 158 centimeters away somewhere. So let me do that in another color. So it has an image over here somewhere, S1 primed, that we know is 158 centimeters. And now we have a second lens with the distance between these two lenses. Let's call that D. That's 315 centimeters. Okay, so now this is S2. This is the S2 is the object distance for this second lens. Clearly, S2 is D minus S1 primed. Okay, so S2 is the separation between the lenses minus the image distance, the image of the first lens. So that gives us the object distance of the second lens. So we need this to find S2 primed. So we can use the equation we were given before, because we know that the second lens also has the same focal length. So the equation we used before was this one. And I could call these things here S1, just so we make sure we know that we keep things clear. So that'll be S2, F2, which is F1, which is, let's just keep it as F, over S2 minus F. And now S2, that's 315 centimeters minus 157.5 centimeters. And this turns out to be 157.5 centimeters itself. So S2 primed is equal to 157.5 centimeters times 35 centimeters divided by 157.5 centimeters minus 35 centimeters. And we get 45 centimeters. Okay, so that's the location of the image now. It's 45 centimeters, so it's somewhere over here. Okay, and we need to determine the height of the object now. So that's we're running out of space, so let's do this on a new page. So first we use m is equal to minus s2 prime over s2. S2 prime is 45 centimeters and S2 is 157.5. That gives me negative 0.286. And now let me call this M2. So now I have y double prime. Okay, so M2 is equal to y double prime over y prime, where y prime is what we found before. That's the height of the image from the first lens. And then y double prime is going to be the height of the image from the second lens. So then y double primed is equal to M2 times y primed, which is 0.286 times 17.5 millimeters. And that gives me 5 millimeters. So remember that the object height was 5 millimeters. And the final image height is also 5 millimeters, so they have the same height. And now we need to determine the orientation of the final image. So then the total magnification will be M1 times M2, and this is what we found before. M1, where did we even find that? Okay, so that's minus 3.5. And then M2 is minus 0.286. And this turns out to be plus 1. So since it's positive, it's erect. So the object and the image have the same orientation. And in fact, the magnification is 1, so the size of the image remains the same. And now we have to repeat all of this stuff for part C, except now D is 45 centimeters. So we'll need S2. Remember, S2 is defined as D minus S1 primed. So the only thing that what's changed now is d, because s1 prime is still s1 prime. So we have 45 centimeters minus 157.5 centimeters, and that is negative, negative 112.5 centimeters. So since now this object distance is negative, we have a virtual object. So that's something to keep in mind. So we want to find S2 prime. Again, we use the equation from before, so that's S2 F over S2 minus F. That's minus 112.5 centimeters. And then F is 35. And minus 112.5 centimeters minus 35. And that gives me 26.69 centimeters. And as before, we need to find the height. So we use m s2 prime over s2, and that's 26.69 centimeters divided by 112.5 centimeters, 0.237. M is greater than 0, so this image is erect here. Well, this part actually, let's say that for the end, because we need to determine the orientation of the final image. And so we have the image height, y double prime is m2 y prime, which is 0.237 times 17.5 millimeters. And that's 4.15 millimeters. And we need to determine the total magnification for us to find the orientation. So remember, we had a minus 3.5 for M1, and now M2 we have positive 0.237. This is a negative number. This is less than 0, right? So the final image is inverted.